Welcome back to Energize. This is the beginning of level 2. Congratulations for making it this far. Let's first review our key point for this quest before continuing on to level 2. Energy exists all around us in many forms. Energy can never be created or destroyed. It is transferred from form to form and can move from one object to another. Heat energy moves from one object to another through conduction, convection, or radiation. Electrical energy is constantly moving. An electric current flows through parallel and series circuits quickly and invisibly from one place to another using conductors and insulators to produce electricity. Level 2 will be on electricity. During this level, you will learn how electricity is transferred in a circuit and how electricity changes to light and gives off heat. Mission 1 will be on static electricity. Our mission objective is to explain how static electricity causes objects to have a positive or negative charge. Our challenge questions: what does the inside of an atom look like? How do objects become charged, and how do charged objects behave? And finally, what causes lightning? Before we get started, I want you to ask yourself these 4 questions. Have you ever heard crackles when combing your hair? Have you ever had cling wrap stick to your hands? Have you ever had clothes get stuck to each other in a dryer? Have you ever got a shock when rubbing your feet on a carpet? If any of these has ever happened to you, then you have experienced some form of static electricity, which will be the material that we cover in this mission. Let's first talk about the inside of an atom. Now, an atom might be a new word to you, but an atom is what all matter is made up of. In fact, they're the building blocks of everything. So I want you to think back to when you were a youngster, and building blocks were toys that you played with, and you could build on top of them from each other. So atoms are the smallest thing that we can see, and everything is made up of atoms. If there were not atoms, then we wouldn't have matter. Atoms have 3 types of particles inside of them. Scientists call them protons, neutrons, and electrons. Here you see a diagram of an atom. The P standing for protons, which have a positive charge. A positive charge is shown with a plus sign. The N standing for neutron. Neutrons do not have a charge. Those are red in the atom. Both the proton and the neutron are located inside the middle of an atom, which scientists call the nucleus. That's not something you need to know for this mission, but that's a good content word for you to know for later on in your academic career. And then finally, we have electrons have a negative or a minus charge, and those are shown with the color yellow in the diagram. Notice how they circle around the nucleus. They're not part of the nucleus, they circle around the nucleus. Matter usually has the same number of protons as electrons. If you look at the diagram, you can see that there are 3 green circles with P's in them, and there are 3 yellow circles with E's in them. Matter usually has the same number of protons as electrons. Electrons do not always stay attached to atoms and can sometimes be removed by rubbing. You see how they're circling that nucleus. They're not attached to anything. So because they're not attached and they don't have a bond with things nearby inside the nucleus, they are sometimes able to be removed by rubbing. How do objects become charged? Well, static charge can build up when 2 materials are rubbed together. Here you see a picture of a balloon rubbing against a wool piece of cloth. When this happens, electrons, those things that circle around the nucleus of the atom, are transferred from one material to the other. If that happens, that means that one material ends up with more electrons, so it now has an overall negative charge, and one material ends up with fewer electrons, so now it has an overall positive charge. Some of the work that you'll do during this mission will hopefully let you see how that exactly works. How do these charged objects then behave, whether they're positive charged or negatively charged? Charged particles can move between objects that are close to each other. Scientists can predict how charged objects will behave because they've done a lot of experiments over the years, and they've written them down just like scientists do. They share their information, and they can see if what they've shared and and seen through their experiments, if that's what other scientists have also experienced. Here you can see from these pictures how charged objects behave. If two objects have opposite charges, they will pull toward or attract each other. That's the top picture. Notice how there's a 1 plus sign and 1 minus sign. Plus standing for positive, minus standing for negative, and how the arrows are pointing towards each other. This attraction causes an electric force, which means a push or a pull between the objects. A charged object can also attract something that has no charge. Let me go back to here. Notice that if there are the same charge, if they're the same, you see negative, negative, they repel each other. They pull away from each other. Static electricity builds up when these positive and negative charges no longer balance. So that means there's either more positive or more negative in that object. Static electricity will then eventually move either gradually or very quickly. I want you to look at this picture that explains what happens during static electricity. Here you notice how there's protons resting on that doorknob, electrons that you picked up from rubbing your heels. The protons will seek out those electrons because of that attraction, and then you will get a spark. So this is demonstrating after you've rubbed your feet on carpet, you are now picking up all these electrons, and there are protons that have remained on that doorknob, and when you draw close to it, those are attracted because they're opposite charges, and so that static electricity moves, in this case, very quickly, and that's where you get that spark. Electric fields are the electrically charged object. The space around that electrical charged object is called an electric field. It's invisible, and it's strongest near the object and becomes weaker farther from the object. An electric field causes an electric force on charged objects that touch it. So notice how the balloon, if it's going to touch that wall, that's going to get some of those positive protons moved on to that balloon because of that rubbing. There will be a Bill Nye video later on in this mission that will really give you a good idea, that it will show you this experiment, and he'll do a very good job of explaining exactly how this static electricity experiment works. A positive electric field attracts negative charges and repels positive charges. Opposites attract. A negative electric field attracts positive charges and repels negative charges. Opposites attract. How does lightning work, and how is it related to static electricity? Here's a picture showing you what lightning might look like. I'm going to look at that picture, and before I start talking about it, what do you think is happening in that picture? Remember, opposites attract. As charged particles move between atoms and storm clouds, those clouds become charged. So there are all sorts of atoms. Remember, atoms make up everything, so there's matter within clouds, and those charged particles have moved around, and now the clouds become charged. With the positive charges at the top, bottom charges are negative, and then it will find some positive charges on the surface of the ground, and that's how we get lightning. In time, this static electricity will be released as lightning. Some of you might have a cat at home. This is not a good idea to do with your cat. You don't want your cat to end up with all of those foam peanuts because they have built up static electricity. Static electricity, remember, builds up when positive and negative charges become close to each other in an electric field. That's when it transfers. So are you ready? Have you answered some of the challenge questions? Have you gone through the rest of the mission and looked at the rest of the videos before you take the checkpoint? Please make sure that you have done that, and then you will be ready to take the checkpoint quiz at the end of this mission.